Soon, Sentinel-6 Mikhail Freilich will be launched on top of a Falcon 9 from the Vandenberg Air Force Base in California, USA. Sentinel-6 will provide near real-time operational measurements of sea surface height, wave height, and wind speed. These measurements allow scientists to monitor sea level rise resulting from climate change, from regional to local scale.
The main instruments on board include a dual-frequency radar altimeter. And this is the primary instrument of the mission, and that's the one that's measuring sea surface height, significant wave height, and wind speed over the ocean. And from those measurements we can actually have the superb measurements that we expect of sea level rise, but also the waves. This is important for marine operations, and the altimeters provide perhaps some of the best data sets that we have today over the global ocean. We have plenty of buoys in the ocean that measure waves, but they're often in the coastal zone, and it's only when you go to the altimetry that you can really have this global coverage.
This brand new radar altimeter is called Poseidon 4 and offers very precise, high-resolution altimetry measurements. Other instruments are used together with the altimeter to improve its accuracy. With its high-precision measurements, Sentinel-6 will be the reference mission for all other altimetry missions. And measurements of other satellites will be compared to the data from Sentinel-6. At first, Sentinel-6 will also fly in tandem with Jason-3, with only 30 seconds between both satellites. This is important to understand and homogenize the differences between successive missions and ensure that the time series of sea level measurements from space remains stable. Long time series are important to understand climate change and monitor a gradual process such as sea level rise. They help scientists gauge exactly how much sea levels are rising and how fast it's happening.
With a long record, we can precisely measure the acceleration. We eventually can detect new regime, tipping points. For example, if there is a runaway in the melting of Greenland or Antarctica, sea level will record this runaway change because it is an integrator of all changes that are occurring in the climate system. So we will be able to see some change, big change in the global climate. I would like to add also that a long record is very important to validate the climate models that are developed to simulate future change.
Sentinel-6 will extend and enhance a series of measurements started by the TOPEX Poseidon mission in 1992. This mission was succeeded by the Jason 1, 2 and 3 missions. And now Sentinel-6 is taking us to the next level. The orbit in which Sentinel-6 will fly is optimized for limited interference from ocean tide changes. And after almost 3 decades of radar altimetry missions, it's well known to scientists. By continuing and enhancing this time series with a new satellite design and high-resolution instruments, Sentinel-6 will allow for further climate research and help scientists monitor the effects of climate change. Its data can also be used to improve ocean and weather forecasting, map seamounts and other tectonic features of the sea floor, and map rivers and lakes for hydrology purposes such as water and flood management. Sentinel-6 is part of the European Copernicus program and will complement the largest operational Earth observation program in the world.
If you think about how, in an Earth system context, Copernicus spacecraft are providing more when they're used together. For example, Sentinel-3 is providing the sea surface temperature and the ocean biology measurements. Sentinel-1 is providing radar imaging measurements of ocean swell waves, of sea ice. Sentinel-2 provides high-resolution measurements in the coastal zone. And when these are used together, a wonderful view of the Earth's ocean can be achieved. It's almost like a painting. As you add more colour, you get a brilliant view of our wonderful planet.
Sentinel-6 is a unique collaboration between the European Commission, ESA, EUMETSAT, NASA and NOAA, with the support of the French space agency CNES. This teamwork underlines once more the satellite's importance and how the whole planet can both contribute and benefit from this vital mission. As sea level rises and our planet continues to change, the lives and livelihood of millions of people are at stake. With 10% of the world population living in coastal zones, less than 10 meters above sea level, we need accurate measurements to prepare and to mitigate the effects of sea level rise and climate change.